Well, you did it. You got through 16 modules of chemistry, and I'm very proud of you. Good job. Let's go ahead and grade the Module 16 test. Number 1, true or false? Oxidation numbers are the charges on atoms if all the bonds in an ionic compound were assumed to be covalent. And they say that's false. And I'm going to read you how they define oxidation number. It's the charge that an atom in a molecule would develop if most electronegative atoms in the molecule took the shared electrons from the less electronegative atoms. And so because that's how they define oxidation number, that's why number 1 would be false. Number 2, an atom has an oxidation number of -3 in a molecule. If it is placed in another molecule whose other atoms are significantly less electronegative than the atoms in the first molecule, what will the oxidation number most likely do? Well, here we have a situation where whatever atom this is, we put it now with atoms that are less electronegative, which means it's more electronegative than they are. It's going to grab more electrons, therefore its oxidation number is going to go down or decrease. So the answer for number 2 would be B, decrease. Number 3, true or false? The sum of all of the oxidation numbers in a molecule or ion must equal 0. That is not true. What they must equal is the charge of that molecule. And it says on page 561, the sum of all oxidation numbers in a molecule must equal the charge of that molecule. So that's what the sum of them has to equal. Number 4, true or false? In the molecule MnO2, the oxidation number of Mn, manganese, is +4. That's true because remember oxygen is -2 and there's 2 of them, so that'd be -4. The charge on that molecule is 0, therefore manganese would have to be +4 for that to be the case. Number 5, what is the oxidation number for O and PO4 -3? If we put our -2 here, we would have -8. We want the whole thing to equal -3. And phosphorus is in group 5, so that'd be a +3. And so that works out, doesn't it? And so it would be -2, which is really what we've put it in all along. So 5 would be B. Number 6, we're supposed to find the oxidation numbers on pH4 +1. Okay, well, and we're looking for the oxidation numbers on all of them. If you'll work your rules, the first rule is it by itself? No, it's not. Second rule, group 1 metals? No. Second rule, third rule, group 2 metals? No. Fourth rule, fluorine? No. Fifth rule, if hydrogen is by itself and it's not with a metal, it's going to be a +1. And so we've got +1 here times 4 is +4. And so this is going to have to equal, be a +1, it's going to have to be a -3, isn't it? And so this would be a -3, this would be a +1. And so the answer to fit that would be D. Phosphorus is -3 and hydrogen is +1. Number 7. An atom changes its oxidation number from +3 to -1. Obviously your bank account's being reduced. So we know that the answer is reduced. Number 8, an oxidation number goes from -2 to O. Well, here your bank account's not being reduced, so obviously this is being oxidized, and that means it's losing electrons, it's losing negative charges. So here the answer would be B, losing electrons. Number 9, true or false? The following reaction is a redox reaction. Well, I mentioned in class, look at the things that are by themselves first, which is real easy. The copper on the reactant side has a 0 oxidation number, whereas the copper on the product side has a +2 oxidation number. So obviously somebody's being, in this case, oxidized. Therefore, somebody else has to be being reduced. And so if you will continue to go through and do the oxidation numbers on that, you will find that in the 2HNO3, and over here, I'm going to put a ... so we're not totally in outer space here, plus 2NO2. Okay. And so here we know that this, if we do our things in order, we know that this is +1, this is -2, and so this is going to be -6 +1, so nitrogen has to be a +5 here. When we come over here, this is It doesn't have a charge on it, correct? I'll find it again. There it is. Nope, no charge. Good. So we have -2, which is -4. So here it's a +4. So here we went from a +5 to a +4. So nitrogen is being reduced. And remember, this has oxidized by the tune of 2 electrons. Well, this is reduced by 1 electron, but there's 2 of them. You see it? So when it asked here, the following reaction is a redox reaction, the answer for 9 would be true. We see that there's a redox going on. Number 10, the following reaction is a redox reaction. Well, here, if you go through and do the oxidation numbers on all these, you will see that they all have the same oxidation numbers from the reactant side to the product side, and therefore it is false. It is not a redox reaction, so number 10 is false. Number 11, what is the purpose of the salt bridge in a galvanic cell? A says it allows the reaction to keep running. That's true. B says it neutralizes the charge buildup at the cathode and the anode. That's true. So C, both A and B are correct, or both A and B, would be the answer. So C would be the answer. If you just did A or you just did B, you didn't make it because you needed to have C where they're both correct. Number 12, true or false? A cell is labeled dry because no water is involved in the reaction. And they've put false because it's called a dry cell because no aqueous solution is in this kind of battery. But if you logic through that aqueous solutions are in water, and that's why you put true, I will accept it. So in other words, whether you put true or false on number 12, don't count off either way, because I personally think I would have logicked through that and said, well, but an aqueous solution is something dissolved in water, and therefore no water is involved in the reaction, and I would have put true. So, like I said, on number 12, don't take off either way. Number 13, what makes a rechargeable battery different from an alkaline battery? A, rechargeable batteries run a reversible redox reaction. That's true. B, a rechargeable battery salt bridge will not degrade significantly when used. That's true also of a rechargeable battery. So the answer is C, both A and B. Number 14, and once again, you had to have C. You couldn't just have A or just have B because both of those are true. Number 14, which of the following is not a difference between an automobile battery and an alkaline battery? So you are looking for the one that is not a difference. A, the automobile battery is rechargeable. That's true. B, the automobile battery uses aqueous compounds. That's true. Remember we talked about the sulfuric acid that's in it. C, the automobile battery is made up of several batteries connected together. Remember the different plates so that we got higher voltage. So that's true. D, the automobile battery uses an acid as one of its reactants. That's true. Therefore, E, none of the above is the correct answer because it asks for something that's not a difference between the automobile battery and the alkaline battery. I don't know if that's the best way to ask that. Maybe they should have said what's true or not true about automobile batteries. But anyway, the answer there is E. Now, it's really hard to write tests. I just want you to know that. I've done it before, and it's really hard. Number 15, you hook a wire to the anode and cathode of a battery. Which way do the electrons flow? Well, remember when we drew them up, we had the anode over here and the cathode over here, and the electrons always flowed in that direction, away from the anode to the cathode, and therefore the answer there would be B, from the anode to the cathode. Number 16. When a metal corrodes, A, it undergoes oxidation. That's true. B, its oxidation number goes from 0 to negative. We don't know that. And oxidation would be the opposite, wouldn't it? C, it is a useful reaction. That's not true. So A would be the answer. It undergoes oxidation. 17. Why must reduction always accompany oxidation? Because there is an electron involved. For something to be reduced, it has to receive an electron. Therefore, something else has to lose the electron because matter is neither created nor destroyed. It can only change form. You didn't have to say all that. You had to say something about the fact that the electron can't be lost, so it's passed from one to the other. So therefore, something is oxidized and something else is reduced. Something about the electron, that you can't lose it. Somebody had to give it, somebody had to take it. Number 18, give the oxidation numbers of all the atoms in the following compounds. So first we have SO2. Well, rule 1 doesn't apply. no group 1 metals, no group 2 metals, no fluorine, so no hydrogen. So now we're all the way up to rule number 6, which is oxygen, which is -2. So this one has to be +4 because there's no charge on it. So those would be the oxidation numbers for A. On B, KClO3. Okay, rule 1 doesn't apply. Group 1 metals, we have one here, don't we? No group 2 metals, no fluorine, no hydrogen. Oxygen is -2. So now we have a -6, a +1. So this has to be +5, doesn't it? And so in this case, chlorine is a +5. So potassium's +1, chlorine's +5, and oxygen is -2. Okay, C, letter C. We have PtCl4 -2. I'm not sure if PT, nope, it's not a group 1 or a group 2 metal. Okay, so that's what I had to look at. So rule 1 doesn't apply. Rule 2 doesn't apply. No group 1 metals, no group 2 metals, no fluorine, no hydrogen, no oxygen. Whew. So we have to go to the really iffy rule, which would make this one a -1, and there's 4 of them, so that would be -4. And we want this whole thing to equal -2, so this one has to be a +2. And there's only one of it, so it's just a +2. So that's what we have for that. And then for N2, rule 1 applies. And because N2 has a 0 charge, nothing's written up there, then its oxidation number is 0. So, yay, that was rule 1. That was easy. Number 19, determine whether or not the following is a redox reaction. If it is, determine which atom is being reduced and which is being oxidized. Excuse me. So we have O2 gas plus Cl2 gas, and that goes to 2. There we go. Okay. Well, obviously, this has an oxidation number of 0, and this has an oxidation number of 0. This one, if you run through your rules, rule 1 doesn't apply. No group 1 metals, no group 2 metals, no fluorine, no hydrogen. So we get to oxygen -2. So this one has to be a +2. So what we have here is oxygen went from 0 to -2. So oxygen is being reduced. And chlorine went from 0 to +2. So chlorine is being oxidized. Number 20, determine whether or not the following is a redox reaction. If it is, determine which atoms are being oxidized and which atoms are being reduced. Okay, so here we have 5HSO3 -1. I'm going to leave out the phase symbols, so please forgive me for that. Yields I2 plus 5SO4 -2 plus 3H plus water. Okay, here we go. Let's look at the guy that's by itself first. That's the easiest one. This is going to be a 0 charge, and this one's going to be a +1 charge. So now let's go over here and see what their charges are. If you work your rules, you're going to get down to where oxygen is a -2, so that'd be -6. This whole thing equals a -1, so iodine has to be a +5. So here it's a +5. Well, over here, iodine's a 0. So we see that iodine is being reduced, don't we? So hydrogen doesn't change. Let's try sulfur. Here, sulfur, if we run through our rules, rule 1 doesn't apply. No group 1 metals, no group 2 metals, no fluorine. We have a hydrogen as +1. Next rule, -2. So we have -6 equals -1 plus 1. So what does sulfur got to equal? Sulfur's got to equal +4, because that would give us a +5 minus 6 would be a -1. So this one's a +4. Let's look over here for sulfur. Here we have it as a -2, so that would be -8. The whole thing has to equal -2, so it's a +6 over here. And so here it went from a +4 to a +6. So in this case, we see that iodine is reduced, and sulfur is actually being oxidized. And you might have gone through and looked at a whole bunch more things to figure that out, but ultimately, that is your answer. Iodine is being reduced, and sulfur is being oxidized. 21. A galvanic cell runs on the following reaction, and it gives us the reaction there. Given this galvanic cell with the electron flow, labeled the anode, cathode, Location of all reactants and products in the positive and negative side of the battery. Okay, so if we have our setup like this, then our anode is over here. Our cathode is over here, which is how we've been drawing all of them. The electron flow lets us know that we are correct in this. That's our electron flow. Then we have our electrodes. Okay, and then we look at the equation, and it starts with barium. Barium, here, I'm going to go ahead and write this here. We have 3 barium solid plus 2 aluminum plus 3, and that's aqueous, yields 3 barium plus 2, and that's aqueous, plus aluminum, 2 aluminums, and that's solid. Now, let's look at this. Here, barium is 0. Here, it's a plus 2. Here, aluminum is plus 3. And here, it's 0. So we see that barium, I don't know if you can read my 2 there. We see that barium is being oxidized, which means this has to be the barium right here, the barium solids right here. And aluminum is being reduced. So the aluminum has to be over here. So we're going to put the aluminum over here where it's got the little line, and then it's got little lines for where you're going to write the cathode and the anode, and it's got a little line for the barium. Does it? Yes, under solution containing barium. So that's what you need for number 21 in those 4 fill in the blanks. Okay, number 22, a galvanic cell runs on the following reaction. Here we have 8H2S plus 8F2 yields 16H plus 16F minus. That's interesting. Plus S8 solid. This should probably be aqueous here, but they don't have a symbol there for that. Okay, and then on the next page, it says, given this galvanic cell with the electron flow, label the anode, cathode, the location of each reactant, positive and negative side of the battery. Okay, so once again, here is our galvanic cell. We already have the electron flow going in this direction. I didn't draw my salt bridge on the last one, and I'm sorry, but they've got the picture there, so we're just trying to fill it in. And so they've got here lines here, 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 and here. Now, because the electrons are flowing this way, we know this is the anode, and it's negative. That's its charge. We know this is the cathode, and its charge is positive. We know those things, so we can write those in up front. Then we got to figure out who's being oxidized, who's being reduced. Well, here hydrogen has a +1 charge, and here fluorine has a -1 charge, and here sulfur has a 0 charge. So let's look at sulfur over here. We work our rules. This is +1, and there's 2 of them, so this has got to be a -2. I can do this. A -2, and it went to 0. So sulfur is being oxidized. So that means sulfur is over here. So I'm so sorry. So we should put here the sulfur's being oxidized. So we're going to put here H2S aqueous. That's what goes there, because that's being oxidized. Let's see who's being reduced. This is 0 here, and yet it's -1 over there. So it's obviously being reduced, and so we would put F2 over here. And so, and you could go ahead and put aqueous if you like. But you know, as long as you got them in the right place, I'm happy. So that's the information that you needed for those 4. For those of you who are not taking the quarterly exams, you're done! Praise the Lord. Okay. Woo. 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 All right. Anyway, yes, I'm excited. You should be excited too. So go ahead and get your final score on that. If you're not happy with your score, go ahead and study it and take it over again if that's what you need to do. That would apply to any of these. I thank you for spending this time with me and for letting me go through this journey with you. It truly has been a journey this year, especially with the new book and all the interesting printing issues that we've gone through, but we've done it together. If you're doing this at a later time, maybe your book doesn't have all those issues. Praise the Lord, that would be great. Anyway, I hope to see you again sometime. Remember that Jesus is the only hope we have, and keep your eyes fixed on him, the author and perfecter of our faith. Don't let yourself get pulled off course. Be in the Word every day. Spend all your time praying, even with your eyes open. Life isn't any fun without Jesus, and so I guess it's not all about fun, but the whole reason we exist is to serve his purposes and do his kingdom work and bring him glory. And I know each and every one of you are very special. And I'm so glad that I got to know those of you that were in the live class. Those of you that were online, I hope to get to meet you. If I do, please come up and let me give you a hug. You don't have to hug me if you don't want to, but let me give you a hug. Anyway, God bless all of you, and just have a really Jesus-filled life. All right. Take care, you guys.